Hey, how's it going, boys and girls? Brad the Guitologist here. In today's video, we've got really classic amp. In my opinion, probably the masterpiece from Marshall. This is a, I don't know, late 70s probably, JMP 2204. This is the one with the stacked inputs, and it has two output tubes for, you know, around 50 watts or so. This, in my opinion, is Marshall's masterpiece, and several reasons for that. I think they really perfected a balance here between, you know, high gain and flexibility. So it doesn't have all of the bells and whistles of newer Marshalls. It doesn't have all the printed circuit board stuff of newer Marshalls either. So we're escaping sort of that downfall from later stuff. And from the earlier stuff, you know, it didn't quite have the flexibility in terms of gain and in terms of the ability to drive preamps and adjust your master. So this has the master volume. To me, this has everything you want in a rock amplifier and nothing more, nothing less. This is the preeminent Marshall, in my opinion. The late 70s JMP, if you're a rock guitarist, this is the business, and to me, this is where it's at. This is something that you can ask yourself, would I do this if I had a classic Marshall? You can see this big hole on the side of the amp, and that is a fan that has been installed there. And does this thing need a fan necessarily? Probably not in a lot of applications. In the vast majority of applications, you won't need a fan like this in your Marshall. In some applications you may, if you're running the amp hot, if the bias is hot, you know, if you're driving the thing and it's a outdoor venue and it's the heat index is high and all that stuff, you might need a fan like that. Just depends on the situation. You could also just simply run a fan on the back of the amp, you know, just get a big box fan and stick it behind the amp and just keep it running through the show, and that probably would do the same trick as this, you know. So, but this at least does have direct injection from the side for a lot of airflow, and probably does help the amp run better. We'll have to see how that's hooked up, the power supply for this, how they're getting power to it, where they're taking it off the board and all that stuff. Make sure that that's within spec too. Maybe look at the fan when we get the back off and check it out. But we'll go ahead and turn this thing around. We'll take a look at the back of it. There have been some modifications on this in the past. The guy said he owned it at one time and then sold it to a guy who did some modifications to it. I think he ran an effects loop or something here, and when the current owner got it back, I guess he undid that, and he also installed this more modern impedance selector for the output speakers. You know, things like that absolutely do not detract from like a collectible value on an amp like this for me. The fan thing, maybe to some extent would. The extra holes in the chassis here, you know, right over this area, maybe. These are becoming more collectible, so as they increase in value and collectability and stuff, I would foresee a time when doing something like this, modifying an older amp like this, is probably not cost effective. It's probably going to end up being better for you to just get a clone of an amp like this, something more modern that's not as collectible, and then do all your mods to something like that, or just build your own, you know, and not deface an old Marshall. Looks like they've mounted the switch pretty decently. They've got it countersunk on there. Looks like that's pretty good. Maybe the effects loop was active or something, because they have another hole here that's been covered up. It's possible they had another tube there at one time. So, you know, that's a bit of a drawback in terms of collectability too. We've got some JJ 6550s. Depending on the time frame for this, the 6550 may or may not have been the tube that this came with. I'm not sure on the cutoff dates on that. Yeah, it's 6550. This is the 6550 version. You can see it written right there. Okay, so they've got 6550 at least here, telling you that if the USA version was 6550 on the tubes. We've got a tongue sole. That's a modern reproduction tongue sole, Russian one, in the V1 position there. V2, we've got another tongue sole, same thing, and same thing there. So we've got a full complement of newer tongue soles on the preamps. 6550s here. It looks like we've got F&T capacitors. So I'm looking for this to possibly not need new capacitors. We'll have to go through this and see what's going on. The guy said his complaint was that he tried to hook this up to several different speaker cabinets, and no matter what speaker cabinet he hooked it up to, it sounded like the speaker was blown. So the amp was producing an output sound as if the speaker was blown. So we're going to try to reproduce, first of all, the complaint. So we'll get this on the back of a 412 cabinet and see if we can't reproduce the complaint first of all. Nothing so far. Got some scratchy pots. Preamp pot's scratchy, and the master volume pot is a little bit scratchy. I can't find anything else. Okay, that's preamp cranked. Master volume about 7 or so, a little bit above 7. I see what he means. Like it's getting a bit hairy and poofy on the bottom end. I wouldn't classify it as a blown speaker. It doesn't sound like a blown speaker. What it does sound like is that there's just too much gain being forced through the early stages, and backing off this preamp slightly is clearing that right up. Maybe he's got the fan turned on when the problem happens. Let's turn the fan on and see if that affects anything. Man, this thing sounds fucking badass. Man, this thing, honestly, other than some scratchiness in the pots, I gotta give this a clean bill of health. I don't see a problem with this at all.
The sound that I was hearing by the amplifier, so when I cleaned it up, I thought I could hear. That's why I got a friend of mine, a guy named Steve, to come over and take a listen to it. And I said, he's been playing two bands for years, and he said, man, I wouldn't run it till we get it checked out. And I said, yeah, I'm not going to do anything to tear it up at this point. So, but yeah, I'm not worried about it being clean, the clean sound. I just want to make sure that, and if you can't reproduce when I'm reproducing, I don't know, maybe somehow it fixed itself. I can't imagine that. And when I got it back, of course, the faceplate was just about wiped clean and had magic marker all over it. So I cleaned all that off of it, and then I laid out that decal that's on the front of it, and then put over the original plate in AutoCAD and took it to a print shop and had a new clear cover printed to go over the original Marshall piece. If you look at it, the numbers actually go to 11.
Yeah, I did not notice. That's cool. He was getting problems with 3 different speaker cabs and 2 different speaker cables. He said he tried, and a couple different input cables as well. So I don't know. Okay, so here we are with this Marshall up on the bench, and yeah, nothing in here really sticks out as being what I would classify as an obvious problem or anything like that. It looks like maybe we have a couple of changed electrolytics along with the big electrolytics. Looks like that one's been changed. These down here in the bias supply have been changed. Everything else looks pretty much original. I'm not sure. Is that a... No, I was thinking that resistor right there looked burnt, but it's not. It's actually a shadow being cast. Just don't have good light coverage right there on that spot, so yeah, that's not what that is. So that resistor is fine. Yeah, everything else, man, in here looks pretty good. You can see the Molex connector over here for that fan. There's that Molex connector for the fan. It's coming up through the chassis, and it's hooking right here onto the main power coming in before the switch, so it's just coming right off of that. Which is fine. I don't necessarily see any problem with that because the fan itself is it's a 120 AC fan, so that should be fine. And I did check the fan to make sure that it was the right spec and everything. It looks fine to me. So yeah, I think we're just going to do some cleaning here. Let's go ahead and clean the sockets and the pots. I want to clean them and then lube them, I think, especially on this pot, because this one and this one particularly were the worst. Okay, this is just contact cleaners. This is I'm cleaning the pots at the moment, and then we're going to replace the lubricant for the pots afterwards. So we'll go through this as kind of a two-step process here. Do all the pots. And now we'll go with some lubricant. I use this Max Pro stuff, electronics lubricant for the pots. And I like this stuff for pots, actually. It seems like it does a pretty good job and stays where you put it. It is kind of a runny substance, so don't spray too much of it because it can kind of go everywhere. But it looks like it does a good job of coating all the internals of the pot to me. Let's spray these right here a second time. I just want to make sure that we have enough lubricant in there. Okay. And we'll flip over and do the sockets as well, the tube sockets. Okay, so there's everything pretty much cleaned. While we're under here, we can see the transformer codes and all that. We can see over here 1202 164. Over here we have 784 139. Kind of hard to see this one. You do have a serial number, chassis number there, 064421, and we have the inspection sheet here. It looks like that says 12/7 of 77. I'm wanting to say that right there says 77. I got it just a little bit damp from the spray cleaner, but the corner's chopped off it. But I think that says 77. So I think this is a 1977 amp. So this thing is as old as I am. Yep, 8 of 77 on that transformer code. 8 of 77 on this one also. You can see it poking through right there. 8 of 77. Yeah, I think this thing is pretty much ready to go. I want to check the fuses while I have it, just to make sure that the correct fuses are in there. You really never know. Sometimes people put the wrong fuses in, and you know, because they're way over spec'd or something, they will work, but they won't really do their job and stop a big current. Should be 500 milliamps on this high tension fuse, and it is 500 milliamps, so that's correct. Yeah, you just never know what people might do in a pinch, you know what I mean? Put in the wrong fuse and then kind of forget about it and leave it, or just not even care, you know what I mean? Oh, it works, and then just go along with their day. So it's always a good idea to check your fuses and make sure that the proper fuse is in the proper spot. Like if this had been, you know, like a 2 amp fuse or something, like a mains fuse put in the high tension fuse position, it wouldn't really be doing anything. That wouldn't be low enough to stop any major problems before it caused damage. This one is it's supposed to be a 3 amp, and it is. Okay, so at this point we've gotten everything cleaned, and we're going to check the bias. I'm going to set the bias, and I want to show you how I set the bias. What we're going to do, I'll just kind of mess up the bias at first here, so you'll be able to kind of see what we're going for. So what we want to do is, with a sine wave on the input here. In this case, I've pumped it up to a 3K sine wave because I think it's going to help us see the crossover distortion a little bit better than our typical 1K sine wave. And we could even go up to different frequencies. If I want to change the input frequency here, I can just I could even do like 4K if I wanted. So just type in a 4 and then kilohertz, and now we're going to have a 4K sine wave going into the amp. I have that injected here into the front end on the high. Coming out of the output, I'm going into the oscilloscope. We've got a dummy load hooked up back here. It's set at 8 ohms, which is correct for the current setting. On the front panel here, as you can see, we've got pretty much everything set sort of straight up. We've got treble and mids straight up here. The bass is cut a little bit because typically on these Marshalls, that's where I set it anyway when I'm dialing in a tone. So I've just kind of cut it down to about 3. It doesn't really matter that much at the kind of frequency ranges that we're dealing with at the moment, but just to prevent a little bit of extra distortion coming from the bass, if we had that cranked, we're just getting rid of that by just cutting it a little bit for now. Presence, we're just leaving straight up. What we want to do is we want to set the master volume all the way up. So that is set all the way up to 11, and these go to 11 because the guy actually redid the faceplate on this, but I think he did a great job. He said he laid all this faceplate out himself, because when he got this amp back from the guy he sold it to for a while, it was completely worn off, he said, and it just needed to be spiffed up a bit, so he went ahead and did this himself. I think he did a great job. So this is like an overlay or something on this, but looks really nice. He did great. He went ahead and made them go to 11, which I thought was kind of neat. So we're going to play with the preamp here, and as we do, we're going to play with this and check out our scope. Right now you can see I'm only seeing part of the wave. I want to see more of the wave I can. But you see right here, it's hard to get a clean wave before clipping. If you look up here on the top of the waveform, let's get a little closer so you can see. Okay, looking at this right now, I've got the bias set really cold. It's all the way down, in fact, on the dial, or on the pot rather. But if we look at the top of the wave right here, it's starting to clip right about there. But we've got all this crossover distortion here in the middle. I want to set that so that it disappears. So what I want to do, so we're going to dial that out. I've got my little trusty screwdriver here. We're going to try to dial out that crossover distortion as much as possible. The problem is whenever you are trying to dial this out, it's kind of hard to see. It's still there, I can tell, but what we're going to do is I'm going to zoom way in on this waveform so we can see it a little bit better. Okay. So here's the waveform, part of the waveform where we're wanting to straighten all of this part out right in here. You can see it's kind of wiggly right there. That's just one half of the waveform. But you can see all of this mess right here. We want to try to dial that out as much as possible. So what we want to do is we want to get this to the point where it's clipping, which is about right there. It's beginning to clip right there, so we'll put it right about there, and we're going to zoom way in, and this little bit right here, we're going to try to get that out of the waveform. So we want that to basically just disappear. So we're going to dial up the bias. This is raising the plate current at the moment, and we're going to I'm turning it slowly, and we should get to the point where we see that waveform right there kind of go, you'll see it sort of go the other direction at some point. Well, that's all the way up. Let's see, let's back down. Okay, you can see that right there. Now let's straighten it out. Right about there is where it straightens out. Right about there. We got a nice swoop to that wave right there. There's not a lot of crossover distortion in that at all. It's just a nice steady swoop to it. Let's see. We can also move this around if we want to see different parts of the wave. But let's see, right there is where we're starting to clip. So let's try that again. We'll look at that wave again, right there. I'm going to adjust the bias all the way back down again so you can see that crossover distortion appear and start to distort in there in the middle of the wave. Now I'm going to turn the other way, and we're just going to keep going to the point where that disappears. And that right there looks to be right about the point where that disappears. So we've got a nice, so that's the maximum amount of headroom before clipping, and that wave is perfect. Now if we turn everything down here and we look at our tail of the tape over here, we look at all of our readings. This is our plate current, 47.8 milliamps, and if we look at this readout, let's get that back on, 380 plate volts. So if we do the calculation on that, it really doesn't matter where the calculation is, honestly, because we know it's right. We're not going to adjust it further than this. We got 0.0478 times 380 plate volts, and that's going to give us 18 watts, 18.1 watts of plate dissipation, and that is, if we divide that by 35, which is the maximum, that's about 51.8% of the total max dissipation of a 6550 tube. That might seem low, and generally speaking it is if we're going by the 70% rule. But we're not going by the 70% rule in this case. We're doing it by crossover distortion, and what that's giving us is that's assuring us that when we dial this thing up, we're getting the maximum amount of clean headroom out of the amp before distortion of the wave form occurs, and that is really what we want. And if we drive the amp into distortion, we're going to be able to get all of the preamp distortion and then drive this thing, usually about 7 or so. We're going to end up looking something like that with a big square wave. But it's not going to be overly distorted as a result of crossover distortion. Might have a little bit in there when we start driving the amp, but that's all looking really, really good. It's not going to overly tax the output tubes at this level. So that's where we are. And if we just look at the tail of the tape on the amp, like if we were to get new tubes and wanted to bias them, we could even get them close just by looking at these figures right here. If we dialed this thing up to 120 or so volts, we should look for the overall current of this at idle to be about 800 milliamps, and we've got 83.5 watts being dissipated in total at idle. An amp that's running properly and healthy should look kind of something like this for this model. But again, there are all of our numbers, and that's kind of what you would probably want to shoot for on yours to get it within the ballpark. And then, like I said, you can just go by the crossover distortion method, which I have been leaning to a lot more lately, because this has given me an exact tail of the tape of what the amp is doing rather than just relying on numbers. Numbers don't always tell you what you need to know. They can get you close, and theoretically, they can be correct, but theoretics don't really do it. You really need to see it. You need to hear it. So in this case, that's where we need to be, and that's where we're going to leave it. 1, 2, 3, 4. 2, 3, 4, 5. right, guys, so that will do it for this video on this 1977 Marshall JMP 2204. You know, I don't really take that lightly when I say that I think this is their best model. They made a lot of great models. You know, of course, they made the Blues Breakers and the JTMs. To me, if I was going on stage with one amplifier and it had to be a Marshall, it would be this Marshall, the late 70s, early 80s JMP 2204. This is their masterpiece in my opinion. If you guys disagree, you're welcome to say so in the comments, but for now, we will see y'all later.